What's up, Math 1? So I'm going to give you all the answers to the Chapter 6 review. I'll slide through all the answers first so you can check your paper, and then I will go back and I will go through every problem, how I did it, and kind of explain it. And you can just slide through the video and find the ones that you missed and look for an explanation if you want. All right, so here we go. There's the answers to 1 and 2 already. And there's number 3. You can, of course, pause the video. And there's 4 and 5, or there's 4A and B. And there's C and D. And there's number 5. And there's number 6. And there's number 7. And there's number 8. And number 9. And number 10, and there's 11, A, B, C, and D, E, F, and G, H, I. Okay, so I hope you got all the answers. Let me go through here and do the problems. So, to do the graphing method, I need to graph each line. This guy has a y-intercept of 4. This guy has a slope of -1, which means go down 1, right 1. So my line would look like that. The other line is also in slope-intercept form. It's got a y-intercept of 12. It's got a slope of up 3, right 1, but I can't really go up 3, right 1, so instead I'll go down 3, left 1. You can see that's the same line. 1, 2, 3, let's see, 1, 2, 3, 1, 1, 2, 3, 1, and I have got my 2 lines. They cross right there. That is the point -2, 1, 2, 3, 4, 5, 6. Oops, how about -2, 6? Looks like I put down the wrong answer. Number 2, -3, -3. So I'm going to graph this line. It's got a y-intercept of 3. It's got a slope of up 2, right 1, or down 2, left 1. I go to the other line. Well, I guess I'd have to subtract x from both sides and divide by -3. And so this line has a y-intercept of -2, and it's got a slope of up 1, right 3, or down 1, left 3. And it looks like my lines cross right there at -3, -3. Hey, I got that one right. All right, so I think we know this, but there is no solution when the lines are parallel because there's no point of intersection, right? The solution is where the lines intersect. So if they're parallel, there'd be no solution because there's no point of intersection. If they do intersect, there'd be one solution. And if they are the same line, right on top of each other, then every point that is on those lines is a solution. So there's infinitely many solutions. Not all, just infinitely many. Number 4. All right, so if I was going to do this one, since a variable is by itself, I would take what that variable equals and I would use the substitution method. So I would write 6x minus 2 times 3x minus 5 equals 10. And I have substituted 3x minus 5 in place of the y. And now I would solve this by distributing the 2. Remember, that's a -2, so you get -6x, but -2 times -5 is positive 10. And then I would combine my like terms and the variables cancel out of the problem. And if the variables cancel out of the problem and you are left with 2 numbers that equal each other, that tells you there's infinitely many solutions. Letter B. I would probably solve this one by the elimination method. So I'm going to rewrite the first equation, but I'm going to take this equation and multiply it by 2. And that gives me 6x, 4y, and -4. Why did I multiply by 2? because I wanted these guys to be opposites of each other. And I recognized that if I multiplied the second one by 2, I would have a -4 and a +4. So I made my opposites. And now I can add these together and get 18x. Those go away, and that's 6. And if I divide both sides by 18, I get x equals 1/3. So I'm going to take that and I'm going to plug that back into the, well, I guess I could do it right over here, the second equation. So plugging into this equation, I get 3 times 1/3 plus 2y equals -2. Well, 3 times 1/3 is 1. And if I subtract 1 from both sides, I get 2y equals -3. And if I divide by 2, I get y equals -3/2, right? All right, we move onward. So since a variable is by itself, I'm going to use the substitution method. I'm going to take this and put it into the other equation in place of the y. And that gives me this. And then I would probably add 2x to both sides, giving me -59 giving me 8x minus 59 equals 11. Then I would add 59 to both sides, giving me 8x equals 70. And then I would divide by 8, and I would get x equals 8.75. And so I would probably take that and put it back into the bottom equation. So I would have y equals -2 times 8.75 plus 11. And I would solve that and get, let's see, -17.5 plus 11. And that would be -6.5. Boom. Letter D. So in letter D, I would do this by the elimination method because no variable is by itself. I would take this guy and multiply him. Let's see. I'm going to make those guys become opposites by making them both into 10s. So I'm going to multiply the top equation by 2 and get +10. I'm going to multiply the bottom equation by 5 and get -10. So I get 6x plus 10y equals 14. And I get 35x minus 10y equals 150. And I have made my opposites. And when I add these equations together, I get 41x and I get 164. And so now you can just divide both sides by 41 and get x equals 4. And I'd probably put that back into the top equation. So I get 3 times 4 plus 5y equals 7. 12 plus 5y equals 7. I would subtract the 12 from both sides and get 5y equals -5. And when I divide by 5, I get y equals -1, right? All right, we're onward. So this is how you know if there is no solution or one solution or infinitely many solutions. I think that's pretty self-explanatory at this point. So then we get to the story problems. All right, so for this section, first of all, for these, you want to use the 98% rule, which is 98% of the time, have your variables represent the answer to the question. The question is, how many of each type of gift can he buy? So I'm going to have my variables be the number of t-shirts and the number of sweatshirts that he can buy. Because that's what I'm trying to figure out. How many t-shirts can he buy and how many sweatshirts can he buy? Then, okay, I talked about in the notes writing about 3 or 4 different types of equations. This equation here has to do with the total number. That is very often one of the equations. he needs to buy 18 shirts, either t-shirts or sweatshirts. So I know that the number of t-shirts and the number of sweatshirts combined needs to equal 18, which is how I got that equation. And very often, the other equation has to do with the cost. I know that he has $180 to spend, and I know t-shirts are $9 and sweatshirts are $15. So 9x would represent the total cost for the t-shirts, right? $9 for each t-shirt, and I'm buying X t-shirts. 9 times X would be the total cost of all the t-shirts. And the same way would work for the sweatshirts. 15 times Y would be the total cost for all the sweatshirts. So if I add together the total cost for all the t-shirts plus the total cost for all the sweatshirts, I get the total cost, which is $180. Total number and total cost. Very often, those are two of your equations. All right, this is really exactly the same problem. How many pounds of each? So there's my two variables. I have one be the number of pounds of M&Ms and one be the number of pounds of peanuts. Again, that's the 98% rule. Have your variables represent the answer to the question. And then again, I have the same two equations here. Total number and total cost. The total number of pounds was right here. He wants to make 8 pounds. So all the pounds of M&Ms and all the pounds of peanuts added together needs to equal 8 pounds. And then we have the total cost. The peanuts are $3 per pound. The M&Ms are $2.50 per pound. Uh-oh, I've made a mistake there. $2.50. Oops, sorry about that. And that's what happens when I go too fast. And so my equation should be 250x plus 3. This would be the total cost of all the M&Ms. And of course, this would be the total cost of all the peanuts. And if you add them together, you get the total cost, which they told you is $21.50, right? Number 8. All right, I think number 8 might be the trickiest problem. So number 8, it's not exactly what the question is asking, but it's what you need to know for the question, and that is how many minutes. So that's one of my variables, number of minutes, and the other variable is the cost. Those are the two things I kind of need to solve for here, the minutes and the cost, so I can see for what minutes the cost would be the same. And then you simply have an equation to represent each of the plans. The basic plan is $10 plus 15 cents per minute. So I have an equation here for the basic plan that says y equals, or the cost equals, $10 plus 15 cents per minute. And of course, I have the frequent plan here. Cost equals $18 plus 10 cents per minute. So I have an equation for each plan. This brings us to number 9. So number 9, the question is, how many dimes and how many nickels are there? So my variables represent the answer to the question. I got fancy this time and have N nickels and D dimes. And then I wrote the same equations. The first equation is total number, which is 30. And the second equation is total cost, or maybe you consider it value, right? So each nickel is worth 5 cents. So if you multiply 5 cents times the number of nickels you have, you get the total cost or value of all the nickels. And each dime costs 10 cents. And if you multiply 10 cents times the number of dimes, you get the total value of the dimes. And then they all add up to $2.60, right? if I were solving this, I would solve it by the elimination method. I would take this equation and multiply it times negative 0.10. That gives me negative 0.10n, negative 0.10d, oops, and negative 3. And then when I add these together, I get negative 0.05n equals negative 0.40. And if I divide both sides by negative 0.05, I get n equals 8. And so I get 8 nickels, and I would take that and plug it back into this equation that says 8 plus d equals 30. And subtracting 8, of course, I get 22 dimes then, right? All right, number 10. The question is, how many roses were sold? So certainly one of my variables is going to be the number of roses. Now, they did not ask for the number of tulips. So maybe that was a little confusing. That happens. But obviously, the other thing in here is the number of tulips being sold. So I had my other variable be y is the number of tulips. Now, this one has a different type of equation in it. In the notes, I call this equation the compare equation, where they compare the two amounts. And up here, they compared them. The number of roses sold was 8 more than 4 times the number of tulips. So I took the number of roses, that's x, and I know that is equal to 8 more. I added 8 to 4 times the number of tulips. So roses equals 4 times tulips plus 8. And then the other equation is the more typical one that we see a lot. It's the cost. The cost of all the roses plus the cost of all the tulips adds up to what they told me was the cost, $414. And if I was solving this one, I would solve it by the substitution method. I would take what x equals and I would substitute it in for x. So I would have 5 times 4y plus 8 plus 2y equals 414. That'd be 20y plus 40 plus 2y equals 414. And if I combine my like terms, I get 22y plus 40 equals 414. I would subtract 40 from both sides and get 374. And then if I divide both sides by 22, I get y equals, let's see, 3, that's 220. Holy cow. 374 divided by 22. I get 17. Y equals 17. Now, that is the number of tulips which they did not ask for. But I can take that and put it back in here to get the number of roses. That would be 4 times 17 plus 8. That would be 68 plus 8, which is 76 roses, right? All right, last section. So in this first one, oops, let's just erase all of these. All right, in this first one, I'm going to subtract 2x from both sides. And that's going to give me, oops, I'm solving for x. So I'm going to add 3y to both sides. That's going to give me 2x equals 9 plus 3y. Then I'm going to divide by 2, and there's my answer. This is a tricky one, letter B. When the x is in 2 different terms, I need to factor out the x, right? Undistribute the x to get it by itself, right? Undistribute. Then you can divide both sides by g plus p, and that cancels out the g plus p, and you have x equals your answer. I'm trying to solve for w, so I'm first going to get rid of this 2m by subtracting 2m from both sides. That gives me p minus 2m. And then, of course, I'm going to divide by 2 to get rid of the 2. And there's my answer. Letter D. Okay, so anytime your variable is in the denominator of a fraction, you need to multiply by it on both sides to get rid of it, or to get it out of the fraction. That will cross-cancel the r, and you will have r times I equals e. Now you can get the r by itself by dividing by I on both sides. And there's your answer, r equals e over I. All right, tricky one here. You need to get the b by itself. So you can't take the square root first. First, you have to isolate the letter with the square on it. So first, I would subtract a squared from both sides. That gives me c squared minus a squared equals b squared. And then, to get rid of the square, I, of course, take the square root of both sides. Now, don't be tricked by this. You cannot take the square root of things that are being added or subtracted individually. This does not equal c minus a. You cannot just take the square root individually of the parts. You just have to leave it as c squared minus a squared. All right, again, in letter F, I'm solving for r. So before I can get rid of the square, I need to get rid of the 4 pi to isolate the r squared. So I would divide both sides by 4 pi. And that gives me s over 4 pi equals r squared. Then I can take the square root of both sides to get rid of the square. And there's my answer, r equals the square root of s over 4 pi. And finally, this one's very similar to a previous one. First, I need to isolate this. Then I will take the cube root. So first, I'm going to subtract b from both sides and have a cubed equals c squared minus b. Then I would get rid of the cube by taking the cube root of both sides. All right, a cube root has a little 3 there. And I would get a equals, well, that's what it equals, the cube root of c squared minus b. All right, this might be the trickiest one. There are a couple ways you could do it, but my favorite way would be first get rid of the 1/2 by multiplying both sides by 2. All right, you get rid of a fraction by multiplying by its reciprocal. That gives me 2a equals h times b1 plus b2. Then I would get rid of the h by dividing by h on both sides. That gets the b1 plus b2 by itself. And then finally, I can get the b1 by itself by subtracting b2. So over here, I'm going to have 2a over h minus b2, and that is equal to b1. All right, then last up, again, I want to emphasize this. The a that you're trying to solve for is in the denominator. To get it out of the denominator, you need to multiply both sides by it. That cancels the denominator and gives you f equals ma. Then you can get the a by itself by dividing by m. And there's your answer, a equals f over m. I hope that helps. Email me this weekend if you have any questions. See ya.